Hello again, this is Professor Shannon Gracie from Miracosta College, teaching out of the Introductory and Intermediate Algebra for College Students by Blitzer. We're on section 7.5, which covers complex rational expressions. So basically here, what's going to happen is we're going to have a fraction, some sort of fraction over some sort of fraction. And there's two methods by which we can simplify these things. You can simplify by dividing, which means getting one happy fraction over one happy fraction, and then doing the procedure you learned before in, I think, 7.2. Or you can multiply the numerator and denominator both by the LCD. So I'll show you both methods, and pretty much it's best if you just pick the one that works best for you and stick to it for now. All right, so here we go. Our warm-up is how we start up. So the first one is something from 7.4, and the second one is just a review of dividing two fractions, two rational expressions in this case. So go ahead and pause the movie and see how you do on these guys. Good luck. Okay, let's see how you did. With the first one, we're going to go a little more quickly. Do you guys see that the LCD will be, let's see, the LCD will be x times quantity x plus 1. So here we'll have x plus 1 over x, and that needs to be multiplied by x plus 1 over x plus 1. And then we'll be adding to that 3x over x plus 1. And what's missing from this guy is simply x over x. Good so far? All right, so here we go. The LCD is x times x plus 1. When I multiply x plus 1 times x plus 1, I'll get x squared plus 2x's plus 1. So we'll have, this is how I got the first one. This here is equivalent to this here. And then moving on to the next one, we'll have plus 3x squared, and that is from 3x times x is our 3x squared. Okay, so when we combine like terms, we'll have 4x squared plus 2x plus 1. That happens to be prime. You have an overall product of 4, and there's no two numbers that multiply to be positive 4 and have a sum of positive 2. So that one is prime, and this one is in factored form. So we're all done. How'd we do? Awesome. Okay, next up. Now remember, the techniques are a little bit different when you're dividing. The goal is to factor the terms, and then you invert and multiply by the fraction that comes after the division symbol, also known as the divisor. So x squared plus x can be factored as x times x plus 1. X squared minus 4 can be factored as x plus 2 times x minus 2. And we're going to divide that by, I'll write it the factored form, we have 12x over 2 times x minus 2. So here's the equivalences from this guy. X squared plus x is equal to this. And then we have x squared minus 4 is equal to this. The 12x, you can see where that came from. And 2x minus 4 factors as 2 times quantity x minus 2. So then we're going to go ahead and invert and multiply. So we'll have x times x plus 1 over x plus 2 times x minus 2 multiplied to 2 times x minus 2 over 12x's. So now we can go ahead and divide out some terms. The x minus 2's divide out to be 1. 2 goes into itself once and into 12 6 times. X goes into itself once. And I believe we're all done. Now remember, once you divide out, you're multiplying across. So that ends up being, 1 times x plus 1 times 1 times 1, etc. So at the end of the day, we will get x plus 1 over 6 times quantity x plus 2. And we're all set. How do we do on that one? Great. Okay, so moving right along. This is how we simplify a complex rational expression the first way, by dividing. Right? So if necessary, add or subtract to get a single rational expression in the numerator. So we want one happy fraction in the numerator. And then again, if you need to, add or subtract to get a single rational expression in the denominator. If we have that kind of situation, then it ends up being like that second warm-up, part B on the warm-up. Then you perform the division indicated by the main fraction bar, invert the denominator of the complex rational expression, and multiply. And then, as always, at the end, you see if you can simplify. Sometimes you can, sometimes you can't. Okay, so here's some practice. I thought we'd start out by using some, regular numbers. Okay, so remember, if you have just a whole number there or an integer, that's the same as having that number over 1. Okay, so using the first method, what we would do is we would say, oh, okay, well, the common denominator of the numerator of the complex rational expression, do you see, is 6. So here I'd need to multiply the half by 3 over 3, and the 2/3 I'd need to multiply by 2 over 2 in order to get 6 in the denominator of the numerator. All right, and then the LCD for the denominator here is 3. So I'd just multiply the 4 by 3 over 3, and that would get me a common denominator there. So here we go. This is going to give me a result of 3 plus 4 all over 6 divided by 12 minus 2 all over 3. Are we good there? The 3 times 4 got me the 12, and then we have minus 2 all over 3. Good. So then I want one happy fraction. I don't quite have it yet. 7 over 6 divided by 10 over 3. Now I have the complex rational expression in a form where we can write it as that fraction bar means divided by. So this is 7/6 divided by 10/3. Well, as you know, when we have a situation like that, we invert and we multiply the divisor. So we flip that 10/3 and multiply by 3/10. So now we can, the 3 goes into itself once and into 6 twice. So at the end of the day, when we multiply across, we get 7/20, and we're done. Okay? So I was really sneaky here. We first did this problem with numbers that we know. Now here, what I did is I replaced the 2 with x, and I basically did the same problem, but instead of having, a 2, I have an x. So this is to kind of extend your knowledge into how you're going to have to do these problems when there's variables. So again, 4 is the same as 4/1. And here, let's not cram it in. So do you see that the LCD of the numerator is going to be x times x plus 1? So the 1/x is missing, and x plus 1. I'll add to that the 2/x plus 1, and that term is missing. You got it. x/x. Now, this is all over. Notice that the LCD of this expression in the denominator is just x plus 1. So we'll have 4/1, and we'll multiply that by x plus 1 over x plus 1. And then we don't need to adjust the second one because it already has the LCD. Okay, so here we go. This is going to give us 1 times x plus 1 is x plus 1. And then we'll have plus 2x, and that's going to be over x times x plus 1. So this is how I matched everything up. 1 times x plus 1 is x plus 1. Oh, I usually do the first one in yellow, don't I? I'll be consistent here. So 1 times x plus 1 gave us x plus 1. And then 2 times x gave us 2x. Okay, and then that's going to be over 4x plus 4 minus 2. Now that 4x plus 4 came from multiplying the 4 through the quantity x plus 1, and we got 4x plus 4. And that's all going to be over x plus 1. Okay, so here we go. We're getting closer. We'll have 3 x's plus 1 when we combine that first numerator, and that's over x times x plus 1 divided by 4x plus 2 over x plus 1. Get that equal sign centered. Let's bring that over here. So now I'm going to factor what I can. We'll have 3x plus 1 over x times x plus 1 is already factored. But I could factor out a 2 from that 4x plus 2, and I'm left with 2x plus 1, and that's over x plus 1. So now this is equivalent to 3x plus 1 over x times x plus 1, that quantity, divided by 2 times 2x plus 1 over x plus 1, just like we did the regular numbers. So now we invert and multiply. And Do you guys see that the x plus 1's divide out? And I believe that's it. So our end result will be 3x plus 1 over 2 times x times 2x plus 1. Now here, remember how we said x was 2? You know, because I was working off the previous problem. So check it out. If I plugged in 2, I would get 3 times 2 is 6 plus 1 is 7. And then that was what I had in the numerator before. 2 times 2 is 4. And then I'd have 4 times 5 after plugging in 2. So I'd get 7/20ths, which is exactly what we got before. I just denoted that x was, going to be, I put in x instead of 2 and worked the same exact problem. All right? So that is the first method. So now what you need to do is practice. So why don't we pause the movie and you can go ahead and practice A and B and see how you do. Actually, there's several problems, so why don't you try as many as you can and then play the movie again and see how you did. Okay, let's see how it went. So here we go. On this first one, you see that again we can write these x's over 1. So it turns out the LCD on each of them will be 5. So if I go 5 over 5 on each of these, I will get the same, I will be able to get one happy fraction in the numerator and the denominator. So this will be 4/5 minus 5x over 5 over 4/5 minus, plus 5x over 5, which will be 4 minus 5x over 5 divided by 4 plus 5x over 5. So now I have one happy fraction in the numerator and one happy fraction in the denominator. So I'll have 4 minus 5x over 5 divided by 4 plus 5x over 5. So now I can invert and multiply. So I'll have 4 minus 5x over 5 times 5 over 4 plus 5x. The 5's divide out, and we'll have 4 minus 5x over 4 plus 5x. Now what do you think? Can I cross out those 4's? What about the 5's? What about the x's? Heck no, we cannot do that. These are already prime. There's nothing you can factor out of the two terms in the numerator or the two terms in the denominator. So believe it or not, you're done. Half the battle in these problems is knowing when you're done. All right, so these are each binomials that are prime, so you cannot divide anything else out. Right? Okay. So, next up. Again, do you see we'll have the same common denominator, and this isn't always the case. So here the first term is missing a y, the second term is missing an x, and the same goes for the denominator. So we'll end up with y times 1 is y, 1 times x is x, so we'll have y plus x, and I'm just going to write it as x times y instead of y times x. And then we'll get y minus x over x times y. So now we're ready to write this as a division problem. So we'll get y plus x over x times y times x times y over y minus x. I inverted and multiplied. The x's divide out to be 1, as do the y's. So at the end of the day, we will get y plus x over y minus x. Again, this problem is trying to sucker you into crossing stuff out. The sign in the middle is different, so these are prime, okay, and they're not exactly the same, so you can't divide them out. Okay. Part C. So let's see what they're missing. Do you see that, again, you're going to have the same LCD in the terms in the numerator and the terms in the denominator. So x squared is the LCD, so that one contains the LCD, the 8 over x squared, and the 2 over x needs another factor of x, and in the denominator, the 10 over x is lacking the factor of x that it needs, and the other one is fine. So we will have, this will yield a result of 8 minus 2x over x squared. I'm going a little faster now. And then we'll have 10x minus 6 over x squared. So we can factor out a 2 from the numerator, and we'll get 4 minus x over x squared. And then also from the numerator of the denominator, we can factor out a 2, and we'll be left with 5x minus 3, and that's still over x squared. And we will have 2 times 4 minus x over x squared divided by 2 times 5x minus 3 over x squared, which will be the division problem. Or I'm sorry, we can switch it to a multiplication problem. Like so. The x squareds divide out to be 1. The 2's divide out to be 1. So at the end of the day, we'll get a result of 4 minus x over 5x minus 3, and we're all done. How are we doing? Feel pretty good about these? If you can get these are like the creme de la creme of, simplifying rational expressions. Okay, so with this one, we already have one happy fraction in the numerator. So we just need to adjust the denominator. Again, notice we've got a 1 over 1. So if we multiply that by the LCD, which is x minus 2 over x minus 2, then we'll be good to go. This one will yield a result of 1 over x minus 2, that's the numerator. Then x minus 2 times 1 is just x minus 2. We'll be subtracting a 1, and that's over x minus 2. So this is what happened there. X minus 2 times 1 is x minus 2. It's all over the LCD of x minus 2, and we're decreasing it by 1 from there. So we'll have 1 over x minus 2 divided by x minus 3, because x minus 2 minus 1 is x minus 3, over x minus 2. That turns into the division problem, 1 over x minus 2 divided by x minus 3 over x minus 2, which we can then invert and multiply. So the x minus 2's will divide out, and we'll be left with 1 over x minus 3. Don't forget to put the 1 over. Remember, 1 times 1 is 1. That's a common mistake I see on exams. Alrighty. So hopefully you've got that method pretty much down. This next method, I actually prefer. Many of my students don't seem to prefer it, but I'll show you both ways, and then you can decide what works best for you. But this is the method where you simplify the numerator and the denominator by the LCD of all denominators in the problem. So here we go. Find the LCD of all rational expressions within the complex rational expression. Multiply both the numerator and denominator by this LCD. Use the distributive property, and this is where people tend to make the mistake in this method. And then you're going to multiply each term in the numerator and denominator by this LCD, and you simplify each term. If you did it right, no fractional expressions should remain. You should have a simplified, well, you should have a mostly simplified single rational expression as opposed to a complex rational expression. So if possible, factor and simplify. Okay, so our old friend, 1/2 plus 2/3, all divided by 4 minus 2/3. We are going to use the other method. So do you see that the denominators that we have in this expression are 1, 2, and 3. The LCD of 1, 2, and 3 is, good, 6. So this is what we do. We multiply by the numerator and the denominator by the LCD, which is 6. So here we go. We will get, now the 6 has got to go with both the 1/2 and the 2/3. So do you see you'll get 1/2 times 6 plus 2/3 times 6 all over 4 times 6 minus 2/3 times 6. So 1/2 times 6 is 3. 2/3 times 6 is going to be 4 all over 24 minus 4, which yields a result of 7/20, which we got before. Whew! Glad I didn't make a mistake on that guy, right? All right, anyway. So this is the idea. Slightly different. So now let's take a look at, again, replacing the constant 2 with the variable x, at least in the denominators, okay? This is how it'll turn out. So now, what is our LCD for all of them. So remember, this is like 4 over 1. So do you guys see that the LCD is going to be x times x plus 1? Because we're doing it for all of them. So you're looking for the LCD of x, x plus 1, 1, and x plus 1, which is x times x plus 1. Okay, so again, and you really need to show this step because it's very easy to make an error. We are going to be multiplying 1 over x times x plus 1 plus 2 over x plus 1 times x plus 1 all over 4 times x plus 1 minus 2 over x plus 1 times x plus 1. So this is just the distributive property, right? The 1 over x multiplies to that quantity, and then the 2 over x plus 1 multiplies to that quantity. So here we go. Notice that on this one, the x's divide out. Okay, so we'll end up with 1 times x plus 1 is just x plus 1. Now on this guy, do you see the x plus 1's divide out? So we'll end up with plus 2 x's. That will be over. We'll have 4 times x plus 1. So that'll be 4x squared plus 4x. So let's get some highlighting so you can see what's going with what. So this here ended up as x plus 1. This guy here ended up as 2 x's. And then this guy here ended up as 4x squared plus 4x's. And then we have one more to go. You see that the x plus 1's will divide out, and we'll get minus 2x's. So that last one came from, let's do, we'll go a different color, we'll do the peach. So this here ended up as 2x. Okay, so we will get 3x plus 1 over 4x squared plus 2x's, which when you factor the denominator gives you a result of 3x plus 1 over 2x times 2x plus 1, which if you remember, that's what we got when we used the other method. All right, so now you get to do a whole another round of problems using this method. So use this method just so you learn how to do it. It's always better to know how to do these things, and then you choose what works the best for you. But use this method for this one. So go ahead and pause the movie, give it a shot, and then roll the movie when you're ready to see how I worked it out. Good luck. Okay, let's see how you did. So again, we have some integers, so we can put them over 1 so we can see the denominators. So do you see that we have a denominator of 1y, 1, and y? So the LCD is y for both numerator and denominator. So here we go. We multiply numerator and denominator by y over y, which if you notice is just 1. So then distributing, we'll have 4 times y minus 7 over y times y divided by 3 times y minus 2 over y times y. So again, the numerator yielded this result. And as you may have noticed, these y's divide out. So we will end up with 4y minus 7. And then the denominator of the rational expression, the complex rational expression, yields a result of 3y minus 2. And this is equivalent to this. All right, and you're done. Nothing to simplify there. Okay, let's move on to the next one. So here we go. Notice that the LCD on this guy is, for both of the denominators would be, they each have an x, they each have a 3. So we'll have 3 times x over 3 times x. So remember, we're going to distribute. If you want, you could put this over 1 to keep them in line if you need it. And we'll be distributing to each term. So we'll end up with 3 over x times 3 times x plus x over 3 times 3 times x, each of them over 1, all over x over 3 times 3 times x over 1, plus, minus 3 over x times 3x over 1. And we'll have, in this one, the x's divide out to be 1. And this guy, the 3's divide out to be 1. So in the numerator, we will have 9 plus x squared over, let's see what divides out here. The 3's divide out in the first part. The x's divide out in the second part. And we'll end up with x squared minus 9. Now we can commute the 9 plus x squared, those terms in the numerator, we can commute them to write them as x squared plus 9. Now be careful, x squared minus 9 and x squared plus 9 will not divide out, but we can factor x squared minus 9 as x plus 3 times x minus 3. So this is how these match up. And nothing more we can divide out, so we are done. See? Now this one can get a little confusing in the dividing out, so I think I'll follow more properties of exponents for this. So here, the LCD Do you guys see we have 3 factors of x is the highest and 4 factors of y is the highest? So the LCD will be x cubed times y to the 4th. So then we will have 2 over x cubed y times x cubed y to the 4th plus 5 over xy to the 4th times x cubed y to the 4th. That will be all over 5 over x cubed y times x cubed y to the 4th minus 3 over xy times x cubed y to the 4th. So again, the numerators match up, or the numerator matches to this here, this numerator. And the denominators match up. This is just illustrating the distributive property. Again, the biggest mistakes in these problems come from when people don't show the use of the distributive property. Now, here we go. Remember that when you're dividing like bases, you subtract exponents. So we're going to have 2 x to the 3 minus 3, y to the 4 minus 1. That's the first part of the fraction of the numerator. Plus 5 times x to the 3 minus 1, and then y to the 4 minus 4. All over 5x to the 3 minus 3 times y to the 4 minus 1 minus 3x to the 3 minus 1 times y to the 4 minus 1. So again, the numerators match up. So then we'll get 2x to the 0, y cubed, plus 5x squared y to the 0, all over 5x to the 0, y cubed, minus 3x squared y cubed. So most anything raised to the 0 power is good, 1. So this simplifies to be 2y cubed plus 5x squared over 5y cubed minus 3x squared y cubed. Now we can take it one step further and factor out a y cubed. I'll bring it over here. It's not really going to change the problem, but just to be consistent, we'll do that. We could factor out a y cubed, and we'd be left with 5 minus 3x squared, but nothing can divide out from that. So we are done. Oops. So how are you doing? I know people aren't too fond of those problems sometimes. Okay, next up, part D. Again, the common denominator. You've got an x minus 2 here, a 1, and then an x minus 2. So the LCD is x minus 2. All right. So we will have 1 over x minus 2 times x minus 2. So notice that that did not require the distributive property because we just have one term times another one there. So that you see that these will divide out and we'll just end up with 1 in the numerator. And then we'll have 1 times x minus 2 minus 1 over x minus 2 times x minus 2. So those x minus 2's will divide out. So this is what we'll end up with. We will have 1 over x minus 2 minus 1, which is 1 over x minus 3. We're all done. Okay. So now in the next example, you get to pick. So just by my experience with these problems, most students prefer the first method. So I'll go ahead and do the first method for you on these. So here we go. You see that in this one, we need to have an x minus 2 times an x plus 2 for our denominator. So the first part was missing the x minus 2. The second part is missing the x plus 2. We should put parentheses around these guys. And then we will have 3x minus 6 minus 3x plus 6 all over x minus 2 times x plus 2 divided by 5 over x minus 2 times x plus 2, because that is how x squared minus 4 factors. So let's line everything up. X minus 2 times 3 gave us 3x minus 6. 3 times x plus 2 gave us 3x plus 6. There is a minus there, so we'll be needing to distribute that through. And then here, x squared minus 4 factors is x minus 2 times x plus 2. All right, so here we go. When we distribute the minus, we'll have a minus 3x minus 6. So the 3x's will zero out, and we'll end up with a negative 12 over x minus 2 times x plus 2. And then that'll be over 5 over x minus 2 times x plus 2. And then we can rewrite this as a division problem. So again, I've been using method 1. And when we invert and multiply the divisor, we'll have negative 12 over x minus 2 times x plus 2 times x minus 2 times x plus 2. Let's move that over a little, make it neater. Divided by 5. So here the x minus 2 divides out to be 1. X plus 2 divides out to be 1. So this one actually simplifies to be negative 12 fifths. Okay. Now B is a wee bit tricky. For B, my advice would be to use properties of exponents to write it more like you're used to seeing. So y to the negative 1 is 1 over y, and then y plus 2, that quantity to the negative 1, is 1 over y plus 2, and that's all divided by 2. So notice that the LCD is y times y plus 2. So this one's missing a y plus 2 over a y plus 2. And the second one is missing a y over y. So this will be y plus 2 times 1 is y plus 2 minus y over y times y plus 2. And I'm going to go ahead and invert and multiply, and that'll be times 1/2. So we will have the y's will zero out, it looks like. So we will have 2 over 2y times y plus 2 and then the 2's will divide out and we will have 1 over y times y plus 2. Okay. Next up is our application. Oh, this is kind of interesting. The average rate on a round-trip commute having a one-way distance d is given by the complex rational expression 2 times d divided by the quantity d over r1 plus d over r2, where r1 and r2 are the average rates on the outgoing and return trips respectively. So let's just say, let's go ahead and simplify this. So 2d over d over r1 plus d over r2. So since I did the last example using the first method, I'll use the second method for this one. So do you see that the denominator, the numerator doesn't have anything in a denominator. It's 2d over 1. So r1 times r2 represents the LCD of all denominators. So if I multiply both by r1 times r2, we will have 2 times d times r1 times r2 over d over r1 times r1 times r2 plus d over r2 times r1 times r2. So on this one, the r1s divide out to be 1, and on the second one, the r2s divide out to be 1. So we will have 2d r1 times r2 over d times r2 plus d times r1. Now what do you notice about that denominator? Exactly, we can factor out a d. So the numerator is still 2d r1, r2 all multiplied together. And then if we factor out a d, we're left with r2 plus r1. So the d's will divide out to be 1. So at the end of the day, we'll have 2 times r1 times r2 over r2 plus r1. That is the simplified form. So now This is the next assumption. Find your average rate. If you drive to the campus averaging 40 miles per hour and you return home on the same route, which means the same distance, averaging 30 miles per hour. So R1 is good, 40 miles per hour. R2 is 30 miles per hour. So here we go. 2 times R1 times R2 over R2 plus R1, given those values for R1 and R2, will be 2 times 40 times 30 divided by 30 plus 40. So I just substituted in wherever I saw an R1, I put 40, and wherever I saw an R2, I put 30, because that was what the problem said. And then when we simplify, we'll get, let's see, 2 times 40 times 30 is 2400 over 70. And it makes sense to approximate this, so just make sure you put the wavy equal sign and you end up getting approximately 34 miles per hour. All right, so we are all done with 7.5. Have a fabulous day. I myself am going to have a margarita, so hopefully you will be doing something fun as well after you do some problems from the homework set. All right, have a good one. Bye.